Imagine you're building a text-adventure game. The player enters a mysterious forest called the Lost Woods. Every screen gives them two choices, go left or go right. If they go right, they see the exact same screen, still lost. If they go left, they escape. Sounds simple to code? It's not. This is why programming needs loops. Let's look at this problem closely. The player enters the Lost Woods. A prompt appears. Choose left or right. Left means escape. The game moves forward. Right means they're still lost. The same prompt appears again. The player might go right once, then left, or right 5 times then left, or right 50 times before choosing left. We have no way to predict how many times the player will choose right before escaping. Your first thought might be, use if-else. If the user goes right, show the prompt again with another if-else inside. If they go right a second time, nest yet another if-else. This is the nested approach. But look at what happens. One right choice needs one level of nesting. Two right choices need 2 levels. 3 choices, 3 levels. Each additional right pushes the code one level deeper. The structure grows without limit. And here's the fundamental problem. You don't know how deep to go. The player could choose right 100 times. You need 100 nested levels written out in advance. 1,000 right choices, 1,000 levels. This approach demands infinite code to handle infinite possibilities. Branching alone cannot solve the Lost Woods. This is exactly the problem iteration solves. Iteration means repeating a block of code multiple times as long as some condition remains true. The condition here, the player chose right. While that's true, show the woods and ask again. The moment the player chooses left, the condition becomes false. The repetition stops and the program moves on. The number of repetitions doesn't need to be predetermined. The loop handles any count. Here's an everyday analogy. You start a new show on Netflix. While there are more episodes, play the next one. When no more episodes remain, you're done. You don't decide in advance how many episodes to watch. Maybe 1, maybe 12. The loop ends when the condition changes. Same structure as the Lost Woods. Repeat an action while the condition holds, stop when it doesn't. In Python, this pattern uses the while keyword. The syntax has 3 parts. First, the keyword while. It appears in blue in most editors. Second, a condition. Any expression that evaluates to a boolean, true or false. Third, a colon, marking the start of the loop body. Below the colon, every line that belongs to the loop must be indented. This indented block is what repeats. Lines at the same level as the while statement are outside the loop. They run only after the loop finishes. The indentation isn't optional in Python. It defines what's inside the loop and what's not. Here's how Python executes a while loop. Step 1. Python reaches the while line and evaluates the condition. Step 2. If true, Python runs every line in the indented block, top to bottom. Step 3. When the block finishes, Python automatically jumps back to the while line and re-evaluates the condition. If still true, it runs the block again. This cycle repeats. Evaluate, execute, jump back. You don't code this looping behavior. Python handles it automatically. A common misconception is that you need to write the jump back yourself. You don't? The cycle breaks only when the condition evaluates to false. At that point, Python skips the entire block and continues at the first unindented line after the loop. The most important danger with while loops, the infinite loop. The loop depends on the condition eventually becoming false. If nothing inside the loop body changes anything related to that condition, the condition remains true forever. The loop runs endlessly. Your program freezes and never terminates. Consider a loop that says, while x is greater than 0, print hello. If nothing inside the block decreases x, the condition never changes. Hello prints forever. Every while loop must contain some operation that moves the condition toward false. Forgetting this is the #1 mistake beginners make with while loops. Now let's solve the Lost Woods with a while loop. First, we ask the player for input and store it in a variable called direction. Then we write, while direction is equal to right, colon. Inside the loop body, two things happen. First, we print, you're still lost in the woods. Second, we ask for input again and update direction. That second line is critical. It changes the variable the condition depends on. Each time through the loop, Python checks if direction still equals right. If the player types right, the loop runs again. The moment they type left, direction changes, the condition becomes false, and the loop ends. After the loop, we print, you escaped the lost woods. This works for any number of right choices. Three key takeaways. First, iteration solves the problem of repeating something an unknown number of times, something branching alone cannot do. Second, a while loop checks its condition, runs the indented block, then automatically rechecks, repeating until the condition becomes false. Third, if nothing inside the loop changes the condition, you create an infinite loop that never terminates. Guard against this in every loop you write. To practice what you just learned, this course has free exercises and AI-graded feedback on ludium.ai. The link is in the description.